Hey guys, Mikey here. So today's video is gonna be on my favorite machine learning algorithm, which is logistic regression analysis. So here we will be just looking at the coding part through a very simple example in R, and we won't be actually going much in depth to the theory part. However, just to give you a brief idea on when to use logistic regression. So use this when your dependent variable is categorical or let's say nominal. So here the predictor variables can be either continuous or categorical, it doesn't matter much. And in this case, even if the model doesn't qualify the assumptions of linear regression, like say for example it is nonlinear and have no constant variance, still it is fine. We can use logistic regression effectively. So now let's jump into the coding part. We'll be working with our all-time favorite Titanic dataset, which I got from Kaggle. You can find the download link in the description section. So here we are doing a binary logistic regression analysis. That is, our response options are limited to 2, that is either 0 or 1. Okay, so once we have loaded our data, let's subset the data for making things easier to understand. In real world scenarios, you will need to do data validation, QA/QC, cleaning, exploration, and all those steps before actually getting your hands dirty with the coding part. Our objective here is to predict whether the passenger under consideration survive or not. So, and like we make this prediction based on 3 parameters, namely age, sex, and fare he paid. So now you can see that we have filtered our data set, but also notice the missing values there. So let's remove them for enhancing the predictive capacity of our model. You can optionally fill in the missing values with other measures like such as mean or median. It just depends on the situation. Now our rows have reduced from 891 to 714, so all the missing rows with missing values have been removed. And now I'm going to build a model using the data which we have. We will be making our prediction on some data which we will be inputting manually. Instead of this, if you want, you can also check the accuracy of your model by maybe creating like a training data set and a testing data set, so you can build the model from the training data sets and you can test it on the remaining data and see how much accuracy you have, how much accuracy your model has. So here we are now ready to make the model, and the functions for fitting the model is actually similar to that we use in linear regression. Here we use the GLM function and make sure that the family lister is binomial, and now we can view our results using the summary function. So here we have information on the upper limits, lower limits, interquartile range, and all those summary statistics, but we are more interested in exploring the coefficients and deviances. So here these values are actually the logits, that is the logs of the odds ratio. From the coefficients we can see that age and sex are having a negative impact. That is, assuming that all the values of other variables remain the same, the chance of survival is less for male as compared to the female. That's what this value, negative value here in front of males denote. And also from the p-values you can notice that age is not actually statistically significant, so we can actually ignore it. And in case of the fare, we can see that a unit increase in fare will actually increases the log of odds of survival by 0.01 unit when all other variables are kept constant. So here this means that like this value will be e will raise to the power of 0.01 units. So that's what it actually means. And notice that the interpretation is slightly different for categorical variable as opposed to the continuous variable. And you can also use the ANOVA function in R to see how adding new variables is affecting the deviance. So we want to keep the deviance as low as possible, so we can see like when we add individual variable how much the deviance is reducing. Here so below we can see there is null deviance. So what it tells us is that how the dependent variable is predicted by this model when only the intercept is considered. That means without any predictor variables. And the residual deviance shows how the prediction is when the explanatory variables are included. So as you have guessed, the lower the deviance, the better. So hence we would generally prefer to have models where the drop from null deviance to the residual deviance is large. And the AIC is an important measure and it's used for model comparison. So imagine you have multiple models which are similar. So in that case, to assess like which model is better or which has less complexity, you will use the AIC value. Like, so you will select the model with the lowest AIC value. Now let's take a simple case scenario and see how our model do the prediction. So here we are having we are just adding a new we are inputting a value with sex male, age 13 and fair 25, and here we write a response since our output should be a categorical variable. So whatever result actually is telling us is that the probability that a person survives is 0.226 when the case is sex is male and age is 13 and fair is 25. And you can like try it with different values for a fair and like age and everything, and you can see, so age is not actually statistically significant, so it doesn't matter that much, but you can see like for 1 unit in fair how the probability is increasing, just like what it was shown in the previous table. So yeah, that's all for now, and thanks for joining, and hope you guys found this video interesting, and don't forget to subscribe. So until next time, bye bye.